Hey, good morning, everyone. Good afternoon. How are we doing today? I'll grab some water and then we'll start. Good morning, good afternoon, everyone. How are we doing today? Okay. We'll start in like 2 minutes or so. Right, I think we can get started. Or maybe first let me grab the blog post of the feature launch. I don't see it. Newsroom? Okay, here. Oh my god, where is this news? Blog? Blog. Okay. Okay. All right, I think we're ready to go. I have here my code editor here. I think I can start the recording. I need access to my AWS account. I need what else do I need? I need my Pulumi account. Yeah, and I think I don't need anything else. I will need this repo. Yeah, all right, I think we're good to go. My Ubuntu machine is also here. So let's press the recording button and get started. Hey chat, how are you doing today? Okay. haven't been streaming for a while, so I barely remember how it's done. I remember that I am supposed to do something, like write some code, and also do some commentary. That's what I remember. All right, let's press this button and get started. Hello and welcome everyone. This is Dmitry, and this is yet another stream where I'll be covering Pulumi. I haven't been streaming for almost 1.5 months, 2 months now. Unfortunately, I was quite busy at work, so I couldn't do this. But yeah, I was able to find some time today, and we actually have a very interesting feature released by Pulumi that, yeah, I think it's going to be great, and I think it's going to be very useful for the whole community. So I decided to go ahead and do this stream. I want to mention that I am not sponsored by Pulumi in any shape or form. I do like the tool. I think this is my favorite infrastructure as code tool overall. So that's the main reason why I often stream about it. I think it's underrated tool on the market. I wish the guys had more market share, so there would be many more resources, many more like code contribution sharing demand for it. So yeah, since I like it, I do want to share a little bit more about it. And this particular feature that I'm going to cover today, it's called cross-language components, if I remember correctly. It was released yesterday, Thursday, March 27th. And I'm streaming this on March 28th, so one day after release. The idea behind this feature, and let's maybe go to our launch blog post. Yeah, so this is an announcement blog post. The idea here is quite simple. Pulumi, you can write infrastructure as code with Pulumi in a number of programming languages. You can write it in Python, you can do it in TypeScript, you can even use YAML, like of course, like other languages like Go, etc. Now, the main way to reuse a piece of code, like have a reusable component or reusable module if you're coming from Terraform, this is called component or component resource in Pulumi. Now, if you think about it, and let's say you do component resource for a collection of resources like VPC, for example. I often do some AWS networking stuff. And you do it in Python. Up until this feature release, only Pulumi Python users were able to use it, right? So that was big drawback, right? So like you limit as a component author, and I'm a component author of like some VPC stuff, and my target audience is now very limited to only folks who use Pulumi Python, which is not great. So now with this, I can write it in Python, but if you use Pulumi in TypeScript or Pulumi YAML, you can reuse some of my component, which I think is amazing. So this opens a lot of doors on both like community contribution side of things, right? Like choose whatever language you like, if it's TypeScript or if it's Python. Publish a component and then anyone can reuse it. Another idea that were shared with me, if let's say you have some central like platform, SRE team, whatever, they can also write in whatever language you want if it's like inside of the company. But like for example, dev teams, etc., they don't have to write the code. They can just write YAML to interface this component that was written by central team, right? So there are a lot of I think opportunities here for both like external community contributions and also like internal code sharing. So I had a chance to beta test this feature, gave some early feedback to the team. Yeah, I think it's pretty good. There are some things that I would like changed, but overall I think it's okay. So we'll try to do it. We'll try to convert our existing VPC component to like from native code to this generic code, and hopefully this will work fine. And yeah, I think with that, let's get started. Maybe like, I don't know, should we read the blog post? Okay. At the core, Pulumi components are logical groupings of resources. Okay. Yep. Bucket. Okay. Pulumi has always supported creating components within a single language, but you can only like do it within a single language ecosystem. Okay. Whatever. Okay, so this is an example. So one of the things that, and we will, once we start like writing code, they, in Python, they do rely on this typedict stuff, where like for all inputs you need to put them in typedict, and that's how Pulumi will then take this typedict, parse it, and then convert it to schema. And this schema can be then converted into like bindings for other programming languages. Okay, 1 second. Let me ban. Okay. Yeah, so you need to group your inputs into this typedict stuff in Python, which I found a little bit not great, I would say, but it's okay. And then you pass this grouped args into your component resource. And that's pretty much it, right? You also need to change this type. It must have index in the middle. And then there are some other stuff. So then after you do this, you can reference it locally. You can put it on Git. Yeah, you can either put it on Git then or reference it locally. And then you can consume it, for example, here from YAML. Like you can consume, or in TypeScript, you can consume your thing. Let's see, what is there in the video? Maybe, you know what? Why don't we go ahead and watch the whole video before I start playing around with this.
Hello and welcome. My name is James Connell. I'm a Senior Solutions Architect here at Pulumi.
Let's go here.
Today I'd like to demonstrate capabilities of Pulumi for authoring components to abstract infrastructure definitions for consumption by end users, which I will show using simple YAML specification. Specifically, I'd like to highlight a separation of concerns between end users who consume component abstractions to provision infrastructure and platform teams who own and create the infrastructure abstractions for those users. Using modern infrastructure as code techniques.
1 second. I see that there is Java example. Is there something else? I don't really want to look at Java code. Java. No, okay, that's fine. We'll.
Platform teams can produce component libraries in any of our supported languages using standard software development best practices and realize benefits of using general purpose languages such as strong typing, unit testing, package management, and semantic versioning. End users can consume these abstractions from any language Pulumi supports, including a basic YAML specification that I will show today. I'm going to use the Java language as an example for component authoring, and would like to highlight a few aspects of Pulumi Java components. First, Java components are simple classes. They can be consumed in any Pulumi supported language such as TypeScript, Python, Go, or via our YAML declarative spec, which I'll talk about briefly. Components are distributed via Git and semantically versioned, and the Pulumi runtime is responsible to download and execute the component as part of the Pulumi lifecycle in a seamless manner. The idea being that component authors working in Java can take advantage of their existing tools and SDLC and easily distribute components to their end users. Pulumi YAML is our simple declarative IaC specification. It's meant to be approachable to users who are comfortable working with YAML, perhaps coming from CloudFormation or Kubernetes. In our demo today, I'll show how Java components are seamlessly composed using the YAML specification. So Pulumi YAML works really well in a number of different deployment scenarios. Today I'll show how we can use these templates in our new project wizard, which allows users to do a basic click-to-deploy workflow. However, there are many other ways we could deploy YAML programs. For example, they could be submitted to Kubernetes and deployed via our Kubernetes operator, or in a more advanced scenario, we can programmatically compose and execute YAML programs using our Pulumi automation API. Let's do a deeper dive on each of these scenarios. Let's talk about Java components in Pulumi. So Pulumi components in general are abstractions that aggregate over sets of related resources. In this case, we're looking at an auto-scaling group with its load balancer, DNS, security groups, etc. And the purpose is to, of course, abstract and encapsulate functionality so that end users only worry about the inputs and outputs of the component. Some characteristics of a Pulumi component in Java. They're just simple classes that extend component resource. We can use class attributes to expose Pulumi outputs to the end user. There is always a class constructor. It takes a specific pattern, so we will give a name for the component. This is the runtime name. We can add any optional parameters. For instance, I have a class here called web environment args, which looks like this. I'm using Lombok to set up the kind of standard builder pattern in Java. However, we can have any sorts of arguments we want here. It could be string inputs, etc. And last, we have component resource options. This is a bag of settings that just controls the behavior of the resource. In general, component resource options can do things like parent relationships, dependencies, deletion protection, and that sort of thing. We always call the superclass constructor and pass it a custom type name. So in this case, we're calling it web index web environment, and it's always in this pattern.
So something interesting here, like two things that stood out to me. So first, like we had component resources in Pulumi for a while. It does seem like the messaging here is that like this kind of way now replaces the old way. So rather than like, okay, we have this and this, it's kind of, I don't know, like at least this is what the feeling I'm getting from this video. So something else is this type. So previously it was kind of like a random namespace or random string, like with these 3 parts, you can put here whatever you want. Since this component resource, there is now, you must have the middle part called index.
We're calling it web index web environment, and it's always in this pattern. Resource declarations. So we build all of our resources typically within the constructor. They're primarily declarative in nature, so we instantiate a resource by calling its constructor and passing in a name and any relevant arguments. In Java, we extensively use the builder pattern to create the argument classes for each of the resources. And for each resource, we can explicitly define its own component resource options. For instance, in this case, I am parenting this security group resource to the web environment. I can also do things like set protection bits here, which would prevent deletion of the resource. As you can see in this example, I have a number of resources. And one thing to highlight here would be that resources can reference each other. So for instance, I'm referencing the key name of the SSH key that I declared above here. Additionally, I'm referencing the input arguments in order to configure this launch template. Java being an imperative language, we can do things like string manipulation within the execution, which is pretty useful. Additionally, we can perform imperative actions during execution, such as fetching information from APIs, databases, file I/O, etc. In this case, we are fetching the zone ID from the AWS API given the hosted zone name so that we can use it to create a DNS record. At the end of the constructor, we register our outputs, so here I'm registering both of those class attributes. Now that we've talked about how to create components in Pulumi using Java language, let's talk about how we can compose those components to create a Pulumi program. This is an example of a Pulumi YAML program. Pulumi YAML is our declarative specification. It's great for teams who aren't comfortable with working in general purpose programming languages and are more comfortable using a declarative specification. For example, teams familiar with CloudFormation can easily create programs in Pulumi YAML and feel right at home. Additionally, it can be used in automation where we want to programmatically compose programs. YAML is a great way to do that. In this case, we have 2 components, a DNS validated certificate and the web environment, which we looked at previously. Within the SDK folder, we have some configuration files that tell Pulumi where to find the component in Git, as well as a version which maps to a Git tag. So we have one for each. The Pulumi engine is responsible then for fetching the component and executing the Java as part of the Pulumi update operation.
I didn't get this part, but it's okay. Okay, 5 more minutes.
So our Pulumi program wants to create the stack. So here we see our DNS validated certificate and our web environment, and all of the child resources under each of those components. So now Pulumi will be creating those resources, and this is going to take some time, so we'll come right back. Okay, so we see we've completed our Pulumi update. The stack's been created, and our front-end URL for our website has been output. It's easy to create a template from our YAML program. Here I've got a template repo in GitHub, and I'm putting my template in this folder. I've copied my project into this folder. You can see I have my SDKs folder and my pulumi.yaml file. And I made some changes to the template. First, I've replaced the name and description with placeholders for the template. And I've added a template section to the YAML. Description.
Oh wait, this part. Where do we get this project and description?
Is going to be the default description for the new project. And config contains the inputs that are required to create a project from the template. These will be copied into a stack YAML.
Config Description, config. Huh.
Each of the config values has a name, description, the type of the input, and optionally a default value. And that's it. The rest of the project remains the same. And we can use this from the new project wizard, which I will show next. Here's an example of creating a new project from a templated version of our YAML program. We choose our project, which is stored in a Git repository. Fill out some project details like a project name, initial stack name, which I'll leave alone, configuration values, which come from our template. You can see the defaults are here. Next, we will choose.
Huh. This one I didn't know about.
Use an IaC environment. This has some base VPC configuration for the template. And finally, we need to put this in a repository. We have the option of choosing a new repository. I'll go ahead and name it.
Didn't know that there is this like form builder for templates.
And I'll put a subdirectory for my stack. When we click Create Project, Pulumi will copy our code into the new repo, set up the deployments agent, and kick off a new deployment.
Huh. I have never tried Pulumi deployment so far, so
We'll skip ahead.
I don't fully know how it runs.
Deploying our resources. And we're done.
Yeah, I think I need to read about this.
We'll paste that into our browser, and we can see that our website is up. In summary, we've shown that we can use Pulumi components in any language, in this case Java, to abstract infrastructure, separate concerns, and encapsulate complexity. We also learned that Pulumi YAML is a great tool for composing components in a simple fashion. It's very accessible to non-programmers and great for automation use cases. Finally, we took a look at the new project wizard and Pulumi deployments, which can help enable no-code workflows for getting infrastructure up fast. Thank you very much.
Okay, so I think this goes, to be honest, like beyond what I expected. So that's pretty interesting. So let's say you build a component, right? Let's say you build this complex VPC. Now, with what was shown, it seems like you can create this VPC without like even touching the code, if that makes sense. Like you can fill in the form, right? And with Pulumi deployment, which seems like to be, you know, like CI, it would just do this for you. Creating a new environment, creating a new VPC, for example. So like you don't have to write any code at all. Kind of like completely self-service. Which is pretty interesting. So I think on one of future streams, I do need to understand a little bit more how deployment works, Pulumi deployment works, because I don't fully get it yet. Like how organizations have any deployments. Like you need some credentials to be able to interact with AWS. Like how that part is being handled, but we can figure it out some other time. It's fine. Right. Let's go back to the announcement. Okay, you can talk. Once you have added an entry to packages, you can run Pulumi install to generate the local SDK. You can do this private repo. There is some comparison table. Yeah, okay. Let's open all of this. Let's keep this part as well. So we'll do Python. Or maybe let me actually see how TypeScript is different. Okay, I think both of them are kind of similar. I do think at some point I want to try TypeScript to actually do a proper comparison. Okay, let's get started. So I think we need to start with, let's create a new project. I'm curious, can I connect my own? How do I connect my own repository here? Okay, maybe some other time. Let's not waste our time today. So let's do YAML. How do I? Let's try again. There was Pulumi YAML minimal or something like this. Let's do minimal. Let's do VPC YAML. Pulumi VPC deployment. Okay. Pulumi GitHub app is not installed. Pulumi deployments use Pulumi GitHub app to create a new repository for your project template. Can I do this? Okay. Let's go back. Pull request comments. Okay, that's fine. Yeah, maybe no. Let's try AWS. Let's try this one. Okay, so I'm curious, like, where do you put credentials here? Authorize GitHub. Okay. Okay, I can do Pulumi deployment now. Okay, so Pulumi AWS VPC stacks. Pulumi YAML program to deploy VPC stacks. Let's do use central one. The rest is whatever. Okay. Environments enable teams to manage hierarchical collection of configuration and secrets. I do suspect that I do need this, right? Create. Okay, we'll keep it. Oh no. Do I have to do it yet again? Oh no. No. Oh, god damn it. Okay. Let's do one more time. YAML, AWS. I want to check something. So Pulumi templates. How do I create a template in my repo? Organization templates are only available to organizations using the enterprise and business critical editions. If you would like to use these features, okay. Right, that's unfortunate. I did wanted to test it with my own template. Hey Pulumi folks, if you're listening, it would be nice to have this in like free version as well, but like limited to 1 or 2 stacks, just so it is possible to play around with this feature, because it does seem like it's a very good idea. Okay, let's do one more time. All right, so static website, Pulumi, AWS VPC, no, VPS, AWS static website. Let's create use east one, maybe EU center one. Use the stack as a template for pull request stacks, run previews. Oh, I suspect I need to add the secrets. Okay. We had an error getting the repos that GitHub has access to. I don't know. What can I say? Ah. How do I make this work? Oh, now it works. I think. What I don't know is how do I get my AWS credentials there. Okay, this didn't work out. That's fine. I will go ahead and create a new project because it seems like I went somewhere else here. So let's do minimal YAML. Let's do one more time. I want YAML and I want minimal. Minimally random. Minimal. Okay. So this will be Pulumi AWS VPC stacks. Pulumi VPC stacks deployed with YAML. Okay, so this should create a new Git repo. Okay. Pulumi. Okay, something else. Let's make sure we run the latest version. Okay. They say you can create stacks. Yeah, okay, we can do this. So I have this Pulumi AWS VPC. Let's go ahead and create a new one. Let's add this here. Okay. Let's just touch some file here. Oh, did it break? Okay. Let's add a new terminal here. Okay. They say pull down your project to get started. Huh. Okay. Okay. Okay, let's go over here. Pulumi AWS VPC. Let's upgrade all of this to the latest versions. So what? UV log upgrade. Okay. 3159. Okay. And then we'll do sync. Okay, cool. Why do I have this virtual environment? V and V. What versions do I have here? 3.9. Okay. UV Python list. Yes, it's installed the latest one. Three 12.9 3.13.2. Oh, UV finally does. UV finally does sim linking, right? Well, at least for 3.12 it did. Let's remove everything that's not used anymore. So 11.9, 12.3 and 3 and 5. Oh, I think it's system Python. 5 and 3.13.1. Okay. Okay. I have 3.9.21. I'm using this over here. Right. So UV what? Run Python? Why does it create? Oh, I think I know what it is. Yeah, this is what. This is why. UV sync. Okay, it created .vnv folder. That's awesome. Okay. We will reference what was sent to me by Julian. Okay. So we need a plugin directory with these files. Pulumi plugin. Inside of it, we need Pulumi plugin.yaml. We need main py. Let's copy this. Yes, so this will be from Pulumi AWS VPC import VPC. We register this and we have a name and we need the requirements txt. Which will go to the directory. So this needs to point to the directory where we have pyproject.toml. So this should be something like this. Okay. So then the next steps. We will get rid of everything except of VPC for now. So let's kill all of this for now. We don't need any of this. Let's start something small. So we need the class VPC args, which is from typed dict now. And this I want to reference in the docs. Build the component, blah, blah, blah. Whatever. Implement the component. Next, we'll implement arguments class. In our example here, we'll pass the contents of the web page we want to host to the component. Okay, we will, let's say, from Pulumi import input. Oh, we also need type dict. I'm curious why our virtual environment is not recognized. This I'm not sure about. So if I do uv run python and I say from Pulumi AWS VPC import VPC. Okay. This is just a typo here. Okay, the input works, import. So what this means is, report missing problem. We like need to what, refresh? In cursor or VS Code, how to refresh to understand that libraries are installed. A reload window. That's what it is. Okay, yeah, so now all imports problems are kind of resolved now. So we'll start with what? With VPC CIDR, right? So VPC CIDR, this will be input str. Let's have some optional input. I think we had it in blog post. Optional bool. Or maybe what? Optional tags. Yeah, let's have this one. The dict should work. Okay. So here, we change our config to args, and it should be VPC args. Yeah, this type. Say resource type this. I'll say AWS networking. It must be an index. Okay. Oh, I didn't put it incorrect place. Let's put it here. Right. Yeah, we will delete all of this stuff for now. This one as well. Let's do self VPC, and then we will self create VPC. I will copy this for now and comment this out. It's fine. We'll say that now we accept VPC arcs. So this will be arcs VPC cider. I think we also had tags. So let's add tags for now. So this will be arcs get tags or something. Right, something like this. Right, so this should allow us to create a VPC. We do need to define an output here. So that's what we will do. So we will say VPC ID. This is output of str. And so something else, we need to make sure that we can reference it here. So we need to have self VPC ID as a property if you want to. Okay. We can also register outputs, but my understanding is that this doesn't do anything. Let's have this. That's fine. Okay. All right, so I think this should work. We have here we'll have here one input is obligatory and another one is optional. And let's see if this even works. Okay, I think this should work. We have to define now. Okay, all of this stuff. Runtime Python. This. Okay. We need to have referencing components locally. For scenarios like monorepos, rapid development iterations, when you're working with components that you don't need to be published, you can reference local source code directly. Let's see example. Yeah, this is what we need. Let's copy this. So this is what Pulumi YAML. Okay. So something interesting here. I don't know if it was mentioned in the docs. Is it mentioned in the docs? Publishing components. Define an entry point, publishing, referencing. No, I don't see it here. Build. Generate SDK. We need requirements. Okay, no, not this one, not this one. This example will show how to create Python package to hold components. Okay, we'll figure it out. Outputs. Runtime YAML, description, stacks, configuration, whatever. Variables we don't need, we need resources. Okay, so we have resources. We'll have resource called VPC, type AWS networking, index VPC, and properties. So this will have VPC CIDR, and this will be 10.0.0. Let's say it's 24 or 22. Maybe let's do /16. And then tax is optional, so we don't need it. Creator properties, yeah. That's fine. And then we need an output. Now here we need to have like this. We actually need a camel case here. Okay. And we need to provide plugin provider path. So provider is called VPC, and the path to it is Pulumi AWS VPC. according to docs here, we do need to create a virtual environment inside of this plugin folder. And it does seem like it must be called venv. All right, so how do we do this? What uv pip no uv virtual env p python 39 venv. Oh no, this is not there. Needs to be done under this Pulumi plugin stuff. So Pulumi plugin. So uv venv python 39 venv source venv bin activate. Yeah, something weird is going on with virtual environments created with UV. They just do not work. UV pip install R requirements txt. Okay. Why this goddamn virtual environment cannot be activated? God damn it. What's going on? Why? Why does it create .venv folder? I don't get it. This doesn't work. No, it still creates this dot folder. What? UV shell. I don't know how to fix this. This is not the first time I'm dealing with this problem. I'm confused. It keeps creating .vnv folder, which I don't need. I can't. I don't understand what's going on. Like it finds .vnv folder higher in the hierarchy. Let me try in something else. Okay, so I have an empty folder. If I say vvnv python 39, okay. Here it works. What makes it not work in my projects? Why? What's going on? I'm really curious why I cannot activate this environment. This makes zero goddamn sense to me. God damn it, finally it's working. Okay, cool. Okay. We finally got this part to work. Right, so here we need to provide, I think it needs to be a pass to the Pulumi plugin. I'm curious if all of these files are at the top level, will this work? Yeah, I think this should work. Okay, so can we deploy? Yeah, we should be able to deploy this now. We need AWS region. Let's do use central one. Let's provide some tags. No, we'll do without tags. Let's just see if this thing works. Right, so Pulumi, what stacks? Stack ls. I need to change a project, but I don't remember how to do it. Project ls. Okay, Pulumi AWS stacks dev. Okay, that's fine. Can I say what Pulumi need? Do I need to do Pulumi need? Pulumi preview. Let's check that I can connect to my account, which I don't think I can because we didn't authorize. Three 186. I don't think this is correct account. Yeah, it should be 29296. We'll do echo AWS profile. Oh, I need to put NVRC here. Oh. Okay. Okay, AWS STS get caller identity. Okay, I can log into my account. Let's check there now. Internal error loading package AWS network could not find the latest version of the provider. Yeah, about that. About that. Plugin providers pass name greeter. Loading package AWS networking could not find the latest version of the provider. somehow it goes and looks for like on GitHub. I don't know. I don't know how to solve this. Do I provide type correctly? Yeah, the same way. And do I use the same type here? Yeah, I use the same type. AWS Networking Index VPC. Let's see another example. Plugin providers, name, Python components. I see. Yeah, I think this first part needs to coincide. Yeah, yeah. I think it should be like this. Yeah. No. A resolving type of resource VPC unable to find resource AWS Networking Index VPC in a resource provider VPC. There is no index here. Okay. Like this. Resolving type of resource VPC unable to find resource type AWS networking in resource provider VPC. Type. Okay, I will try. I had an example in my other branch, so I think I can try to do that. I don't remember how I made it to work. Okay, here I had AWS networking name. Yeah, the first part needs to coincide. Yeah, this part needs to coincide, I think. And here I had a resource type. Yeah, okay. So this was here. Like this, hopefully. Yeah, finally. Okay, we are getting somewhere. So now we have a property VPC cider. It does use this camel case stuff, so it needs to be camel cased here. All right, I think we will get this to work now. Excuse me. I don't know what is this. Unexpected input of type method for VPC ID. Okay. I think this is some property stuff. Yeah. We need to have it as property. Please work. Yeah, this seems like this is going to work. Okay. Let's do Pulumi up. I'll come back in a second here. Let's do the update. All right, so if we go, so we deploy this one. Okay, VPC was created, so that's good news. Don't need this. Okay, we have this new VPC, so that's good. We finally got somewhere. Awesome. Okay, so let's deal with tags now. Did we do tags? There are no tags. Okay, so let's have a name, right? So name will be input str. Let's provide here a name. So this will be Pulumi YAML. Oh, this doesn't do anything. We had a function here. Common tags, and keyword arguments. Okay. type VPC object has no attribute build tags. Okay, unexpected attribute tags. Okay, so let's try to deal with this. So we had here an optional. I don't think you can provide default arguments here at all. Yeah, you can't provide default arguments. So when you do optional, this will be passed as a non downstream. Okay. So this is what I will start doing. So I was dealing with this typedict stuff quite a lot. I really didn't like it. So what I will be doing in my own programs is I'll be doing something like this. Okay, let's uncomment this. Let's do something like this. So have to duplicate until Pydantic is supported. If I do want to use Pydantic and I want, so that I have some default values. I'll have to do something like this. Oh, what is this? This is incorrect. How was this working? Doesn't make any sense. Yeah, this is incorrect. Okay. Let's do this. So class VPC cider. This can be IPv4 or IPv6. And can have cider. It can have IPAM pool. And it can have a size. Okay, and VPC config. So this will need to be in the VPC siders. And we'll have IPv4 and list of the siders and IPv6. Maybe we can even say IPv4 sider or IPv6 sider, and IPv6 by default is 56. Okay, let's remove this stuff. So primary siders will be siders IPv4 0. Something like this. This I don't care about. Okay. So siders will be VPC siders. Okay. Okay. So this one needs to be typed dict. This one can be optional, but IPv4 is obligatory. And it would need to be the same thing, arc. Or maybe I can have one, VPC, cider, arc. So we'll have cider, optional, CR, we'll have size, and we have ipample. Okay. All right, so VPC arcs, this should be VPC cider arcs. Okay, this should be a list of disk objects. So this should be, oh, well, I'm confused now. VPC cider args. Something like this. So our input will be now ciders IPv4. Yeah, something like this. Okay. So the next thing we need to do is take our mega dictionary and convert it to self-config. So that we'll have self VPC config, model validate args. Okay. Hopefully this works, which I don't think it will, but we'll see right now. VPC resource. VPC has a problem while processing input VPC ID type class str. An expected input of type IPv4 VPC cider for cider block in VPC. I know. Let's delete this VPC for now. I'm even confused where exactly the error is. We have this IPv4 VPC cider. While processing input VPC ID. Yeah, I don't know how to troubleshoot this. While processing input cider block. So what I think is happening is it needs to use... Oh, no, it's fine. It's fine. I see what's wrong. Uh, yeah, it's because I deleted it in the console. Okay. Okay. This works. Cannot assign. Property common tag doesn't exist. Okay. I'm curious how these tags will be sent out. Okay. Okay, this looks good. There is one thing I really want to do. There is a parameter called DNS support. Let's do this false first. I shouldn't have done it. Let's provide a key called extra, and this will be dictionary of str to any, and it's optional, of course. I don't remember how Pydantic works though. Ah, of course. What? Do I need a dictionary? I think I need a dictionary. Pydantic private. Not treated as fields. Oh, there is my bug from really long time ago. Okay, this is our case. Also note, yeah, I don't understand this. Will this work? Yeah, okay, I think this is workable solution. Yeah, this is good. What I want to do is to be able to pass this enable DNS host names, kind of like as an arbitrary attribute. Yeah, optional dictaster any. Yeah, something like this. Or maybe it should be like args or something. Args. Or props. All right, let's have extra. So what this will allow me to do is to do this. All right, so Let's try running our stacks again. Okay, moment of truth. If I now say here extra enable DNS hostnames true, will this work? Okay, currently DNS is disabled. Right, please work. If this works, then it's going to be insane. Right, cannot assign. We want to have this as an underscore. Cannot assign. Extra does not exist. Property extra does not exist. Okay, I think I made some mistake there. Yeah, I'm concerned that it just doesn't like any cannot assign. Let's try renaming this to extra. Just in case. Got multiple values for keyword argument enable DNS support. Yeah, I think so. This one. Yeah, this is Python problem. I think we need to build a dictionary first. So the way we would need to make this work, this would be extra args. Like this. Please work. Please work, please work, please work. Nice. Look at this. I am able here to deal with like arbitrary arguments. That's pretty awesome. Yeah, that's cool. All right. This is what I'm looking for. Okay, let's wrap up. I'm tired now. Yeah, so Pulumi component resources cross-language ones. Pretty cool stuff. You can write component in whatever language you want and then use it in arbitrary language. Like you need to figure it out at first of some of these parts. But once you get it to work, it's pretty straightforward. I wish we had a native support for Pydantic, which we currently don't, but it's okay. So what I do instead is, as a first step, I get the arguments and I convert this to Pydantic, and this simplifies a lot of stuff going forward. Yeah, so overall, very useful feature. Yeah, I think it's time for me to wrap up my VPC module, publish it, and then anyone using Pulumi can use it. All right. Yeah, thank you so much for being here, and yeah, until the next time. Bye bye.